Welcome.
Sorry I'm late. These shoes maybe walk in.
2.5 minutes.
With you.
Let's go through. One minute, 30 seconds. Welcome, sanitize your hands for me. Here, I'll just put it in. So if you can't do A, do B. If you can't do B, attempt C. 45 seconds. All I need is one bed. All right, just for the sake of time, we're going to start with C. So C is the product rule. Bases are the same. What am I going to do with the exponents? Very good, I'm going to add them, so it should be 2 plus 5. So my answer should be x to the 7th. What about for group B? What do I do with B? Subtract. They have both have the same bases. So I subtract the exponents. So that means I'm going to get x to the 5th as my answer. Okay? And then what about A? What about for A? Yeah, I'm going to multiply. So x to the 3 times 5. So it should be x to the 15. So you guys reviewed exponent rules this week. Next week we'll be doing factoring. So every week the bell ringer is going to be like a review of something that you are going to need for your EOC. All right. So take a minute or two to finish writing that. All right, so this was exponent rules. What we're going to do is we are going to review yesterday's work. All right. If you need to write some of this out, you're more than welcome to. This was the work from yesterday, the notes from yesterday. So your mini lesson was linear exponential, and they wanted you to determine the difference between a linear and an exponential function. All right. So what I have on the board is the first part of the notes. If you don't have these notes, you may write what you need. So Mr. T said, write what you need last period. I'm going to emphasize what he also was saying. They don't give us enough time to do note-taking strategies. They don't give us enough time to do test-taking strategies and talk about the content. So we have to kind of do it together. And sometimes when that happens, we don't get the opportunity to have the depth of understanding that we should. So if you don't understand something, I must ask you to make sure you are going home and you are taking advantage of the time that you're given to practice, okay? I can't expect all of you to be writing all of this out word for word, so I'm just going to point out the things that I would like for you to emphasize on your piece of paper if that's possible. The first thing I would like to emphasize is this is a linear function, y equals mx plus b. Is there an exponent in this function? No. Is there an exponent in this function? Yeah. So here's the thing. With linear functions, you have your slope, which is your m, and you have your y-intercept, which is your b, okay? Same thing goes here. B is your y-intercept, but instead of x being within the equation, now it becomes a part of the exponent, okay? So what we're going to do is once we get to it, we're going to practice inputting x time. When they talk about time, you'll be inputting a value there, okay? So the difference between a linear function and an exponential function in an equation is that linear functions don't have an exponent. Exponential functions have an exponent. They are written like this. So if I had to ask you to write the things that I would like for you to write, these would be what I want you to write right here. And then draw a quick graph of what a linear graph looks like. It doesn't have to be perfect, okay? So these are the 4 pieces of information that I really, really, really would like for you to get out of this front page. Nothing to write? It's okay if you don't. Just know that I'm not going to be slowing down, all right? If you don't get it, all right? So the next part would be how to determine from a table. So you have a equation that you have to determine if it's exponential or not. They give you a graph that shows you the difference between linear and exponential. And now you have tables that they show you. You have to be able to understand how to even determine what is linear and what is exponential from tables. All right. So as of yesterday, you guys determined what the common difference is, which is the difference between each y value. And then with exponential functions, you have a common ratio, which is what you multiply each by to get to the next y. We're going to practice these in a little bit. All right, so these are the 3 pieces of information that you will use, the 3 different tools to understand exponential versus linear, okay? So what we're going to do today is, yeah, I guess we'll get it all together. Now, I'm going to hand this out right now. We're all going to work on this together. I don't know what the results were for the exit ticket y'all had yesterday. All I can do is go off what Mr. T said. Mr. T said that you guys understood the definitions or the words per se, but I had trouble with applying those words. And that's all right. We're going to go over this today. And what's going to happen is that we are going to determine, starting off by a table, how to determine points, okay? So this first problem says, and I'll put it up on the board closer, all right? An art collector buys 2 paintings. The value of each painting after T years. T is going to be the time. So instead of it being y equals mx plus b, T is just the variable now because we're dealing with time, okay? So what they're saying is you have 2 different tables. One table represents the linear growth, and one represents the exponential growth of the 2 different paintings when it comes to its earnings in years. So your T is how many years you've owned it in both circumstances. So what we are going to do is, let's read the rest. We need to figure out which painting's value has a constant growth rate, which painting's value has an increase in growth rate, okay? So what we're going to do is we're going to fill the tables out first. Now, can anybody tell me, how do I evaluate? What do we do when we evaluate something? Same. Who said it again? Okay, so let me get more. What happens when they give us a value for time? And then in an equation, you have that same variable being used. They give you a value for a variable, and they want you to see what the value at that value is time. So I'll just give you the example, first one. So it says at 0 years. So what I would do is I would take the equation, and instead of the t, what am I going to put there? Yeah. So for 1 year, what I'm going to replace the t with what? Yeah. And then for 2 years, what am I going to do? Okay, so here's what you're going to find. You're finding your y value or your answer. So what is, and you guys have calculators, so what is 19 times 0? 0, and then what's 0 plus 5? 5. So that your first answer, 5. And then 19 times 1? Yes, then plus 5? 24. Okay? Somebody other than Isaiah, tell me what you got for your answer for year 2. Lols. What? What's 19 times 2? No. You're good. 38, and then 38 plus 5 is what? 43. It's okay. Just the fact that you're answering is good. So what about the third year? At year 3, what is the first equations? What's 19 times 3? 57, and then 57 plus 5? 62. And then what's the last one? I will not give you your answer. Okay, so now let's do the other table. They give us the years, so what we're going to do is we're just going to take the equation and replace t with the value that they give us. So this first one becomes y is equal to 3 to the 0. What does this next one become? 3 to the first, and then to the second. So use your calculators to find the answers for this, please. So okay, so your question is it's the same thing? So we're just trying to find our answer. So what's anything to the 0 exponent?
0.
Close. 1. Okay, so what's 3 to the first? 3. You have calculators, right? So what's 3 to the second? It's 3 times 3. Use your exponent button. So what's 3 to the third? So the button that you're going to look for on your calculator is the one that goes x to the y. So everybody, or y to the, yeah. So everybody on your calculator, let's look on your calculator, and it says x to the, y to the n, wait. Y, let's see, 3 to the, stupid calculators. All right, I'm going to show you on the screen how to do it.
Yeah, that button, yeah.
Okay, so 3 to the third. Where is my scientific calculator? Okay, so you should have a button that looks like this. I presume this is how we do it. So we're going to do 3. See how it did to the? It won't show it on yours, I don't think. But so now we can put a 3 in.
I mean, it comes out like X.
Oh, I have a button.
I promise with practice we'll get it. So 3 to the third is 27. 3 to the fourth. Let's do that on our calculator too. Okay, so 3 to the fourth, 3. Here's the button I'm going to click right here. To the x to the y. So it's 3 to the fourth. What do we get? 81. Okay, so now what we have to do is we have to find the common difference or the common ratio. So to determine if it's constant or increasing, you have to determine what the difference between each of these are. So if you have this problem right here, I have to determine what's the difference between 24 and 5? What's the difference between 43 and 24? What's the difference between 62 and 43? So somebody subtract 24 minus 5. What do you get? You have a calculator. So it's plus 19. What is 43 minus 24? You're subtracting this answer from the previous. Oh, okay. So just based off of that, let's do one more. What's 62 minus 43? Yeah, so they're all 19. So that is a common, am I multiplying, adding, or subtracting? So, yeah, so it's being added or subtracted. So it's the common same number in between each. So what is the type of growth rate that you have here? Huh? Constant. Constant is constant. Okay. I'll give you one for your brother's. So that means that this is a constant change. All right? So circle constant. What's the constant change that you're seeing? Yeah, so we can honestly say, there you go, that it's going up by 19. So we can say, good to see you, Jordan. If you need anything, just text me on my phone, okay? So it's constant, the growth rate of 19 units. It's a common difference. This is a difference. What about this other table right here? If I subtracted 3 from 1, what would I get? What about 9 from 3? So does that mean that they're the same differences?
No.
So what do I have to do here? Yes, but I'm going to show you how to get your answers. What you're going to do is you're going to divide. So you do divide the second answer by the first. So what's 3 divided by 1? Okay, so that means that I had to multiply 1 times 3 to get that second answer. What is 9 divided by 3? 3. So that means I had to multiply by 3. What is 27 divided by 9? Are we starting to see a pattern now? Yeah, so each one of these has a common multiplier of what? 3. So that means that this is an increasing, and it has a constant ratio. So it has a ratio, constant ratio of 3. All right, so that's the constant ratio of 3. So with a linear equation, you will have a constant growth and a difference that you have to find. With an exponential function, you will have to use the common ratio or find the common ratio. All right, so what we're doing is we're distinguishing between the situations that can be modeled with linear or exponential functions. Linear is a constant that goes straight. Exponential is always going to be like a L, like a zombie apocalypse. Okay? So the best example I can give you is zombie apocalypses are exponential functions. If I was a zombie and I bite Aziz, he's infected, we're both infected. One person goes to 2 people infected. If we go and bite 2 people, now there's 4 people infected. So zombie apocalypses are exponential growing. Like viruses do that. All right? Man, it would be nice to all have our mouth stuck out at the same time. So I want y'all to redo your exit ticket because I don't think that we did well on it. Okay, so what we're going to do is we are going to redo. Yes, ma'am. So I want you to redo your exit ticket. And the fun part about this is going to see if I'm going to be able to pull this up. I mean, so listen, all I can do is. Did I what? What test? No, I haven't yet. Okay, so guess I can't do that yet. It's 10:41. Y'all get it at 09. Let's go ahead and do this next part then. Oh. On the same part of your notes, let's talk about comparing the graphs, all right? So what we have to do is we have to take our answers that we just had, and we have to create ordered pairs. So my first order pair would be 0, 5. For this next one, it would be 0, 3. So what kind of points are those? What kind of points are it when you have a 0 value for your x, and then you have a actual value for your y? So let's say if I graph the first point, 0, 5. So am I going to go up or down on the y-axis? 1, 2, 3, 4, 5, because it's a positive 5, right? So that's my first point, 0, 5. What about for this one? 0, 3, 1, 2, 3, same thing. Okay, so if we look at these points, can you tell me something about these points? What's going on here? Is there something about these points that sticks out to you? Can you name, is there a term that we learned about points that reside on an axis? What are they called? Do you remember?
Linear?
Okay, so if we go back to the initial, let's see. I want to get the, so here, you have two different graphs, right? So if I point at the graph where what is this point called?
The X or the O?
Yeah, you're on the right path. Say it, X what?
No.
X. Yeah. So this has an x-intercept on this one. So what that means that if I had to label this point, what would be that point? It would be like -1, 0, right? Yes. So that means that there's an x value but no y value. So what do you think this is going to be then? If you have a y value, a y value but no x value, what is this type of point called? What type of intercept is it called? Y-intercept, because of what?
Because it's on the y-axis?
Yeah. Okay, so if you could please transfer your answers that you just got into these tables, okay? And then I want you to attempt to graph these really quickly. So take the answers that you just got from the previous problems, write them into the tables for me, all right? Mr. Myers, you do me a favor, will you take a picture of this and send it to Mr. Myers at work? Because I can't get my phone out. Okay, so you did 0, 0. Ooh, I got the first one wrong. Sorry, I stink. First one wrong. I apologize. I did not mean to. All right, so 0, what was it's 1, right? So 0, 1. And then at 1 hour, what is your answers for both? And at 2 hours. So somebody give me my answer for the linear, sorry, for the first problem. At 2 hours, sorry, 1 hour, what was my answer here for this first problem? At 1 hour, what did I get? 20 what? 24. Okay. And then what was the next one? 43. And the next one? 62. Okay, so now let's take a real close look at this because I know what you guys are thinking. Those numbers are huge y values, right? And I didn't put the point on the right place. So if I'm going to do 0, 5, I'm going to have to probably go up by 10. So 10, 20, 30, 40, 50, 60, because, not even that, because my y values have to be in the scale that makes this work. So let's go ahead and graph this together. I'm sorry I had that point there. So 0, 5, let's say that 0, 5 is like in between. Let's say we're going by tens. Okay, and then the second one is 1, 24. And then the third one is 2, 43. And then the fourth, 3, 62. And now these are very, very rough drawings. 4, 5, 81. Very, very rough drawings, okay? Do not judge me.
You add 5, right?
Say that again?
You add 5.
The common difference is 19 for this. So between each one of these, there's 19. Okay, so then you connect the points. They don't have to be perfect. 0, 5, sorry, that was like that right there. It's a very rough graph. So 0, 1. These are going to be really, really rough. 1, 3, 2, 9, 3, 27, 4, 81. Okay. Those are the two different types of graphs. So if you could please, for the next 5 minutes, I want you to attempt to draw, to describe the characteristics of, which one's linear, the left one or the right one? The left one's linear because it looks like a line. So what can I say about this problem? What words have we learned so far to describe? So like here's a couple things that you could use, some words that you could use. You can use the difference, common difference, and then constant ratio. So is the problem we're working on, is that a linear or a exponential function? So we are going to use common difference or common ratio. Common difference, linear, common ratio, exponential. So what can I say about this linear problem? What's the common difference again? What's the difference between each one of these values? Plus what? Plus 19. So that means a common difference. So common difference is equal to 19. Is there a y-intercept somewhere? Where is it in this problem? It's wherever your x value is equal to 0. Yeah, what is it? Yeah, so it's 0, 5. That's your y-intercept. And now tell me if it's constant or if it's increasing. Is this first problem constant or increasing? Constant. Very good, Aziz. Because of why? What type of function is it? Yeah, so a linear function is always going to be constant. Now let's finish up. So with exponential functions, you will have a common ratio. The common ratio is what you have to multiply each y value by to get the next one. So remember that we multiplied by what for each problem? Yeah, so we multiplied by 3 by each problem. So that means the common ratio is 3. Somebody other than Isaiah, tell me the y-intercept. So if the y-intercept for this problem right here was 0, 5, because the x was a 0 value. Yeah, there you go. So your y-intercept for the second problem is going to be 0, 1. And now is it constant or increasing? Increasing, because it's an exponential function. Very good, very good. We're not going to do the next part. I am going to ask you to do the X ticket. We're going to redo the X ticket from yesterday, just to make sure that we got it. All right. So you're going to turn this in too because I want to see the difference from yesterday. So if you need to, grab a piece of white paper. I just want to see what you know from yesterday, okay? So let me turn this on. Here's your exit ticket. You have until the end of the period right here. Exit ticket. There's white paper right here. Let me go ahead and cut some for you so you have pieces. Come on back and grab a piece of paper. Everybody at home, you will turn this in after you get done with it, okay? Make sure you turn it to the back. There you go. You are welcome. You don't have to write the question, just write your answers. Please answer everything that you can see, okay?